Today, we will be looking at fractional linear equations. In this first example, we want to make sure that everything is in fraction form. So let's do this. This was a 4, a whole number 4. So let's change this whole number 4 into a fraction by saying 4 over 1. This will not change the value that there was a whole number 4 here, because 4 divided by 1 will still give you 4. Okay? The next step is we want to make the denominators the same. So let me times this by 4, times this by 4, times this by 3. What you do down, you do up as well. Times this by 3, times this by 12, times this by 12. Because the overall aim of this is we want to eliminate the fraction part. That's why we are doing that. Okay? So 2x times 4 will give you 8x. 3 times 4 will give you 12. Plus 3 times 3 times 3 will give you 9. And 4 times 3 will give you 12. Equals to 4 times 12 will give you 48. 1 times 12 will give you 12. And just like a normal fraction, when the denominators are the same, we just cancel them out. Okay? Then everything just comes down as it is. 8x plus 9 equals to 48. Now this we can work with without any complications. Okay, so maybe I'm rushing too much. What we did, we had a whole number 4 here, so we decided to turn it into a fraction by saying 4 over 1. It won't change its value. The next step was we wanted to make the denominators the same so that we get rid of the fraction part. So I times this. This is the LCM, which is 12. Okay, so after I did all that, I got 8x over 12 plus 9 over 12 equals to 48 over 12. Since the denominators were the same, I decided to cancel them out, just like you would do with a normal fraction. Next, you bring down the numerators as they are. Now we can work with this. Now our next step is we want to isolate the unknown variable by keeping it on one side of the equal sign, and then we move the rest on the other side. Okay, so 8x comes down as it is. 48, we're gonna move 9 this side, and when you move the 9 on the other side, its sign changes from positive to negative 9. All right, so 8x equals to 48 minus 9. We can work with this because these two are like terms. 48 minus 9 will give you 39. We still have to isolate the variable by dividing both sides by 8. So 8 divided by 8, these two will cancel out. Then you get x. All right, 39 divided by 8, you get 39 over 8. So therefore the value of x in this original fractional equation is 39 over 8. And if you want to verify, substitute this 39 over 8 into this equation. And if this side, the one side of the equal sign, if both values on either side of the equal sign are the same, that means that this is indeed the value for x, 39 over 8. In this next example, we should make sure that everything is in fraction form. So let's change this whole number 3 into fraction form. It won't change its value because 3 divided by 1 will still give you 3. Next, let's make sure that our denominators are the same. So I'm going to times this by 10. What you do down, you do up as well. So I'm going to times this by 10, this by 50, by 50, this by 5, and this by 5. All right, so here we have 10, 3 minus x. You can still put the 10 this side or this side, it doesn't matter. We're still gonna multiply this 10 with everything inside, over 50, because 5 times 10 is 50. Then next we have 3 times 50, which is 150 over 50 equals to 5, 2x plus 1 over 50. Now, since the denominators are the same, we're just gonna bring down the numerators as they are, because the denominators are cancelled out. So you have 10, 3 minus x plus 150 equals to 5, 2x plus 1. Now, there are brackets involved here. Like I said in the very first part 1 of linear equations video, when there are brackets involved, we should eliminate the brackets by multiplying everything outside with everything inside. So you're going to multiply this 10 with everything inside and this 5 with everything inside. That's the only way we can get rid of the brackets. So 10 times 3, 30. 10 times negative x, which is negative 1, will give you negative 10x equals, plus 150 equals to 5 times 2 will give you 10x, and then 5 times 1 will give you 5. I hope you did not forget the table in the part 1 video of linear equations, that a positive value times a negative value will give you a negative value. All right, the next step is we want to keep the unknown variables on one side of the equation and keep the rest on the other side. Here we have negative 10x, and then here we have 10x. So we can either move this 10 this side or this one this side, right? So I'm going to move this negative 10x this side. So we have 30 plus 150 equals to 10x plus 5. Since we're moving negative 10x on the other side of the equation, its sign will change and become positive, plus 10x. We are not done yet. We still need to isolate the unknown variables on one side, but we have this 5 here. It is no unknown variable. So let's move the rest on the other side of the equal sign. So we have 30 plus 150. Since it's positive 5, when you move it this side, it becomes negative 5. Negative 5, 10x plus 10x. Okay, next, since this this side we have like terms and this side we have like terms, we can solve them. So we have 30 plus 150 minus 5, we are getting 175, and then 10x plus 10x will give you 20x. We are not done yet. We need to still isolate our unknown variable. So the next step is to divide both sides by 20. These two will cancel out. Then you get x. 175 divided by 20, you get 35 over 4. So if you want to verify if x is indeed 35 over 4, where this x, you put 35 over 4 in the original equation, which was 3 minus x over 5 plus 3 equals to 2x plus 1 over 10. So just substitute this 35 over 4 where there's x. And if both sides of the equal sign have the same value, that means that 35 over 4 is indeed the value for x. But I know it is, but if you want to verify, you can do that. So therefore, x is equal to 35 over 4. In our next example, we should make sure that everything is in fraction form, and yes, everything is in fraction form. The next step is to make the denominators the same. So we have m, our unknown variable, as a denominator. So how we're gonna go about this is, first, what's the LCM for 3 and 4? The LCM for 3 and 4, the lowest common multiple, is 12. So let's multiply this with 12. What you do up, you do down. 12. Let's multiply this with 4. Let's multiply this with 3. So that our denominators can be the same. But since we have m here, let's multiply this side with m as well. 4m, 4m, 3m, 3m, just so that our denominators can be the same. So next, let's multiply. 5 times 12 will give you 60 over 12m plus 4m. 12m equals to 9m. 12m. Now our denominators are the same. If we had multiplied this with just 4 and this with just 3, we'll just be getting 12 and 12 without the m. But the aim is to make sure that our denominators are the same, which we just did over here. Now we cancel out the denominators because they are the same, and the numerators come down as they are. 60 plus 4m equals to 9m. Next, we want to isolate our unknown variables by moving them on one side of the equal sign and the rest on the other side. I'm going to leave 60 this side, and I'm going to move my 4 on the other side of the equal sign. You can decide to move your 60 this side and then your 9 this side, but just to make it easier, let me just move my 4m this side. 9m. When you move 4m this side, its sign changes from positive to negative. Minus 4m. 60 equals to, since 9m and 4m are like terms, I can solve them. 9 minus 4 will give me 5m. Still, we need to isolate our unknown variable. So we have to divide both sides by 5. The 5 will cancel out, then we have m. 60 divided by 5 will give you 12. Therefore, our unknown variable m is equal to 12. If you want to verify, substitute this 12 where m was in the original equation. And if both sides of the equal sign have the same value, that means that m is indeed 12. Our next example, let's make sure that everything is in mixed fraction form. So we have this variable c. I can put this in fraction form by saying c over 1. It won't change its value because c divided by 1 will still give me c, because there's an invincible 1 here. So if I remove the 1's, the c just comes down as it is. Next, we have this mixed fraction. Since I don't want to work with mixed fractions, I'm going to change this into an improper fraction. So 3c over 5 minus c over 1 equals to 2 times 2 is 4 plus 1 is 5. 5 over 2. Now everything is in fraction form. The next step is to make the denominators the same. So I'm going to times this with 2. What you do down, you do up. 10, 10, 5, 5. Because the lowest common multiple of 2, 5, and 1 is 10. Next, we multiply them out. 3 times 2 will give me 6c over 10. And then c times 10, don't forget the sign, will give me 10c over 10. 5 times 5 will give me 25 over 10. Since the denominators are the same, I'm going to cancel them out and bring everything down as it is. 6c minus 10c equals to 25. Next, we want to isolate the unknown variables by moving them on one side of the equal sign. Since this is already done for us, we can already solve this. 6 minus 10, since they are like terms. 6 minus 10 will give me negative 4. Negative 4c equals to 25. And we are not done yet. We still have to isolate that unknown variable c. So we divide both sides by negative 4, both sides by negative 4. These two cancel out. We have c. 25 divided by negative 4 will give you negative 25 over 4. Therefore, the value for c in this fractional linear equation is negative 25 over 4. In this last example, we need to make sure that everything is in fraction form. So I'm going to change this whole number 7 into a fraction by saying 7 over 1. Next, let's make the denominators the same. So the LCM of 1 and 2 is 2. So I'm going to multiply this by 2, multiply this by 2. This x multiplied by 2, multiplied by 2. But I need to multiply this 2 with x as well, so that everything can have x, 2x, 2x, 2x. Okay? Let's multiply them out. 2 times 2 will give me 4 over 2x plus 3 over 2x equals to 7 times 2, 14x over 2x. Now our denominators are the same. What I did here, I feel like I'm rushing too fast. So what I did here is make sure that everything is in fraction form, and then the next step is to make the denominators the same. The LCM of 1 and 2 is 2, right? But we have x's involved here. So I multiplied this with 2x and I multiplied this with 2, so that our denominators can just be 2x, 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 the same. Now we cancel out our denominators because they are the same and bring the numerators down as they are. 4 plus 3 equals to 14x. The next step is to isolate that variable, which is already done here. Now we can solve this because they are like terms. 4 plus 3 is 7. We bring down the 14 as it is. Next, we isolate the unknown variable x by dividing both sides by 14. These two cancel out. When these two cancel out, we have x. The x just comes down as it is. 7 divided by 14 will give you 1 over 2. 7 divided by 14 will give you 1 over 2. Therefore, the value for x in this fractional linear equation is 1 over 2. If you want to verify, substitute where this x in the original equation, and if both sides, if values on either side of the equal sign are the same, that means that x is indeed 1 over 12, 1 over 2. Do try these three equations, A, B, and C, for practice.